So, we're going to do a nice bit today now. Right, simplifying algebraic fractions. So, these are the basics from junior cert. So, we're going to look at these ones first and then jump straight into the leaving cert ones. So, off you go. Simplify that for me. Right, so first thing first, we get the lowest common denominator of 6. We get the lowest common denominator of 6. 2 and 3, lowest common denominator of 6. 2 into 6 goes 3 times x. Bring down your minus. 3 into 6 goes 2 times 5x minus 2. 3 by x is 3x, minus 2 by 5x is minus 10x, minus 2 by minus 2 plus 4. 3x minus 10x is minus 7x plus 4 over 6. Right, have a go at this one. Simplify that. Algebra on the bottom. Same concept as the last. Right, so same as the last time, we get the lowest common multiple, which becomes our lowest common denominator of x plus 1 and x plus 2, yeah? We then divide x plus 1 into that, and you're left with 2 times x plus 2. You divide x plus 2 into that, you're left with 1 times x plus 1. 2 by x is 2x, 2 by 2 is 4, 1 by x is 1x, 1 by 1 is 1. Simplify it, you're left with 3x plus 5 over x plus 1 and x plus 2. Right. That is leaving some parallel, figures of parallel and leaving some ornamental. Example 3. Do this thing. Mark the parallel stuff now. So it's the exact same concept, except it's just triple fractions this time. Right. Nice long one for us. Right, let's have a little look at it and see how far we got in it. So, we divide x plus 1 into that, that's gone. It's 3 times 2x plus 3 by x plus 4, plus 4 times 2x plus 3 into that, you're left at x plus 1 times x plus 4 minus 2 times x plus 4 is there, so you cross it off, you're left at x plus 1 and 2x plus 3. So the easiest way not to make a mistake on this, guys, is x plus 1 is here, you go down and you block it off, and you multiply the top number by what's left. If 2x plus 3 is there, you cross it off, and you multiply the top number by what's left. X plus 4, block it off, you multiply the top number minus 2 by what's left. It's easy for that. Which one? Oh, right. I took down the wrong one. That should be x plus 2, should it? It will make a difference. X plus 2. Anywhere is an x plus 4, put an x plus 2. Right, let's go ahead in. Easiest thing to do, lads, is leave the 3 on the outside. Multiply the brackets, 2x by x, 2x squared, 2x by 2, 4x, 3 by x, 3x, 3 by 2 is 6. Plus 4 times x by x, x squared, x by 2, 2x, x, 1 by x is 1x, 1 by 2 is 2. Minus 2 times x by 2x, 2x squared, x by 3, 3x, 1 by 2x is 2x, 1 by 3 is 3. So 3 times 2x squared is 6x squared. 4x and 3x gives you 7x. Times 3 is 21x. 3 times 6 is 18. Plus 4x squared. 2x and 1x is 3x. 4 times 3x is plus 12x. 4 times 2 is 8. Minus 2 times 2x squared is minus 4x squared. 3x and 2x is 5x, minus 2 times 5x is minus 10x, minus 2 times 3 is minus 6. Right, all the x squared, 6x squared, 4x squared, and minus 4x squared. That leaves you with just 6x squared. Gone, they knock each other off. Go back and do, obviously if you don't have a highlighter, lads, I'd recommend underlining these so you just don't make a mistake. All the x's, 21 and 12 is 33. 33 minus 10 is plus 23x. And the last one then is plus 18, plus 8, minus 6 is 2 and 18, plus 20. 6x squared plus 23x plus 20. One of these will come up, not off the bat, but it'll come up in the middle of a question. This is the most common place to make a mistake by literally just not paying attention and rushing it. Alright, take your time when you're doing these. The multiplication is the easiest place to drop marks on the leave insert. Simple like that. Right, so that's a leave insert one. You also have these types of ones. Where are we gonna? Right, these are known as complex fractions. And the reason they're known, the reason they're known as complex fractions is you have a fraction over a fraction. Alright? So get our heads around these and make sure we know what to do. These are the most difficult type of fractions and the ones that come up actually individually on rows. these are the type of ones we individually come up with on exam day. If I ask you, what do we do here? We touched on it last week. How do we divide those two? Flip up the second one multiplied. So it's a half multiplied by 3 over 2. Yeah? Which is 3 over 4. Right. Also, if I ask you to do this, 2 divided by 2 thirds. How do I do this? Slightly different now from the whole number instead of a fraction, one over fraction. Yeah, exactly. What's any number over when it's on its own? 1. Very, very important to know. So that's actually 2 over 1 divided by 2 over 3. And then you say 2 over 1 multiplied by 3 over 2, which is 3 times 2 is 6 over 2, which is true. Alright? So 2 things to take there. When you're dividing fractions, you flip and you multiply. Whenever you see a whole number on its own, or anything on its own, it's actually always over 1. So when we come over here, first things first, x and y are actually. Go on, Adam, yeah? Perfect, man. X over 1 and y over 1. So there you have x over 1 and y over 1. And instead of 1 over x and 1 over y. Alright? So, as I said, you don't feel the need, you want to take these down with we go up and down. There's no actual need to take down if you don't want. Right. What we have to do here then is create a single fraction at the top and a single fraction at the bottom. So, how am I going to create a single fraction at the top end? So, you're actually physically forget about what's at the bottom. Maybe just concentrate at the top. Well, they're both over 1, but create a common denominator. Common denominator 1. So 1 into 1 goes once by our top, which is x. 1 into 1 goes once by our top, which is y. So the exact same thing we were doing here around with when we 2 fractions. Alright, the exact same thing. We're literally forgetting about the bottom of the time. We're only focused on x over 1 and y. So x over 1, 1 into 1 goes once by our top, which is x. Plus comes down. 1 into 1 goes once by our top, which is as we said, next step was x over 1 plus y over 1 over 1 over x. 1 over y. So the next line was create a 1. 1 into 1 goes once by our top, which is x. 1 into 1 goes once by our top, which is y. So that is still over 1 over x plus 1 over y. You all okay so far? So, our top line now looks like x plus y over 1. Is that alright? On our bottom, we have 1 over x plus 1 over y. So what do you need to do in the bottom now? Exactly. So, top is different. We're now focused on the bottom. So how are we going to change the bottom into single fraction? What we did last time? Common denominator, what's the common denominator we just x and y, good stuff. Divide x into x, y goes, you get out. Get out of y. Divide x into x, y, you cover out, we're left with just y by our top number, which is 1 plus. Divide y into y, x, y, we're left with. Divide y into x, y, we're left with x by our top number, which is 1. So, now now you have your x plus y over 1. There's your top. Over y times 1 is y less x over xy, which is your bottom. Alright? So that's where we are. So here's where we are. X plus y over 1, x plus y over xy. All I need down here is the x in front of y. Alright? So we've now created single fraction on the top, single fraction on the bottom. Right? It couldn't work. We fraction to fraction and two. It was all only 4 fractions for all the world. So we have to now turn it into a single fraction on the top and a single fraction on the bottom. What was I saying a minute ago as regards algebraic two fractions? You flip the second one end, multiply. So x plus y now becomes multiplied by xy over x plus y. This is tough to get a head around, right? Don't worry about it. Anyone spot on? Good stuff. So we're multiplied by an x plus y on top over here, and you're multiplying by an x plus y on the bottom over here. Do you want to cancel? So you're left with xy over. There you go. Alright, I'm going to show you one of these. Hello at this one. Right, off you go. Simplify that. So remember what I did up here, I split it the top and bottom. Same concept. Worry about the top, worry about the bottom, and then worry about the two together. Right. Faye, I'm going to let you do the top. So what happens on the top? X over 1 minus 1 over 3. Perfect. Which becomes? So 1 into 3 goes 3 times x. Minus 3 into 3 goes minus 1 times 1. Like that? That breaks down into 3x minus 1 over 3. Add them, the bottom. One into 2 goes 2 times x. 2 into 2 goes minus 1 times 1. Which, as you say, it breaks down into 2x minus 1 over 2. So now we have our top and our bottom. Oops, sorry, it wasn't on the screen. Abby, two fractions divided by each other. How do I divide them? I flip the second one end. Brilliant, good stuff. So that becomes 3x minus 1 over 3 multiplied by 2 over 2x minus 1. Just tell me if I'm right and there's nothing come up on the screen as I've got on froze. So nothing is cancelling this time, so we literally have to multiply out the top and multiply out the bottom. 2 times 3x is 6x minus 2 over 6x minus 3. 2 by 3x, 6x, 2 by minus 1 is minus 2. 2x by 3 is 6x, 3 by minus 1 is minus 3. Alright? Right, slightly harder one of those. Have a go at this with me. Anyone know what b to the power minus 1, a to the power minus 1 actually is? What is it? 1 over b and 1 over a. Yeah, 1 over b and 1 over a. Like if we had this 3 to the power minus 1, if you fire that at your calculator, it's actually 1/3. Right, let's look at it. So, trigger out. It's alright, small little trick. On the top and bottom. So on the top, once again, freeze, Paddy. B and A. Divide B into B and A, you're left with A by our top line, which is. Divide B into BA, you're left with A and top line, which is A. Minus. Divide A into AB, and you're left with B times B. Yeah? A by A squared minus B by B squared over BA. Bottom. This is 1 over B minus 1 over A. So you have a bottom line of BA. B into BA goes 1 times A minus A into BA goes 1 times B. 1 times A is A minus B over BA. Right. There's our top, there's our bottom. What do we do? Flip them and multiply. So our next line should read A squared minus B squared over BA by A minus B multiplied by BA over A minus B. Right, what happens? BA cancel. Boom, boom. Got it. We're now left with A squared minus B squared over A minus B. Close. Difference of two squares was part. Square term and a square term and a minus in the middle. This is A minus B by A plus B over A minus B. What happens? A minus B is cancelled. B equal to A plus B. Alright, these take a bit of work. I think there's 4 of them in the homework for the weekend. All pretty much the exact same thing. Alright, so I'll let you have a whack off them. Nothing really much changes. It's going to be bringing 2 fractions together on the top, 2 fractions together on the bottom. There's 1 or 2 slightly harder ones with like x plus 1 and stuff like that, but the whole sequence doesn't change. You're just trying to make 1 fraction on the top, 1 fraction on the bottom, and then flip them and multiply. Exact same sequence for all of them. Is that right? Right, jumping into simultaneous equations. Start with the basics. I'll do these in a minute. Right, get me an answer for this. Go. What do we get? 4 minus 1, exactly. Cancel your x's, cancel your y's even. 4x equals 16, divide across by 4, x equals 4. Sub it back into your top line, 2y equals 2, divide across by 2, y equals 1. Right. Have a go at this one. So that's the basic simultaneous equation, the first one you're going to come across. Off you go. Solve this one. Practical application. be able to create an equation. At an even sort of level, bar the train a triple, it's going to be a practical application. Alright, so you have to be able to do the practical application ones. The trick to this is you got to be able to make notes. You got to make notes on your line. What I mean by notes is, for example, the sum of. So sum plus, right? You think plus there. Two numbers, we don't know the two numbers, x and y. Get it? 11 minus 3. So let's look at the sum of two numbers is 9. So we know when you add x and y, you get 9. Twice the first number, we call the first number x, so 2 times x is added to 3 times the second, 3 times y, and the answer is 15. When this comes up in the exam, obviously it's going to be hard when this comes up. You've got to make little notes of it. That's how you get out your equations. So simply x plus y is equal to 9, 2x plus 3y is equal to 15. Solve it like any normal simultaneous equation. Minus 3x minus 3y is equal to minus 27. 2x plus 3y is equal to 15. Minus 1x is equal to minus 12. X is equal to 12 as well as it says down here. Sub it back into the top line. 12 plus y is equal to 9. Y is equal to minus 3. Alright, so it's all about being able to apply it. So it'll come up as a basic simultaneous equation. It'll also come up as a practical application. Right, I'll go with this one. Right. This is also on, not the Junior Show Ireland course, on the Deep Show Ireland course. What is it? This is linear and quadratic. Hey, why is it linear and quadratic? Do you know what linear and quadratic is? Very important, isn't it? Linear and quadratic. Linear, straight line. Quadratic is either U or M. Alright? Which one of those is linear? So, linear. That's linear. And linear. Quadratic. Quadratic. Right, which one of these is positive, negative? This one is positive, it's going up. This one is negative, it's going down. Which one is positive, negative? That one is negative n for negative, positive. The u for positive. Alright, so very important. So, with these, that's what they look like on the graph. Which one of these is linear, which one of these is quadratic? Top one is linear, bottom one is quadratic. What actually specific type of quadratic one is the bottom one? Is that? X squared plus y squared. Quadrant junction. Alright? X squared plus y squared, quadrant junction. We're going to do it. So the top is linear, the bottom is quadratic. How are we going to be able to solve this and this? Show me. Finding terms of x, get either a value for x or get a value for y, whichever one is easier. So if we're getting a value for x plus y is equal to 3. Take out the linear. The linear one is one without the square root. Take out the linear one, get a value for x. X is equal to 3 minus. Oh, I got y this time. Doesn't make any difference. You either find for y or find for x. Y is equal to 3 minus x. What am I going to do with this guy? Sub it back into my quadratic instead of y. Or, yeah, 3 minus x squared is equal to 5. Any idea why I'd sub that back into this? What's that? Yeah, because we know y is now it's all. X, what to do? Square it out hand. Simplify it. So x squared is equal to 3 minus x squared by 3 minus x equal to 5. X squared is equal to 3 times 3 minus x. 9 minus 3x plus x squared is equal to 5. And to simplify it, 2x squared minus 6x plus 4 is equal to 0. What do I do with that? I have 2x squared minus 6x plus 4 down here. What do I do? No, but you can't see it down here. There. What do I do with that? Okay, what's that now? Value number minus b. Alright, value number minus b. So that is 2x squared minus 6x plus 4. Your guide numbers are your minus b formula, whichever you feel comfortable, or bracket. Get out an answer of x equal 1 and x equal 2. What to do then? Sub it back into the top equation. What do you get? Y. Y is equal to 2. And sub it into the other one. Y is equal to 1. So there I have my points. My points are 1, 2, and 2, 1. So when I use my minus b, I got my values for x, and then I got my values for y. What do these mean? What does 1, 2, and 2, 1 actually mean? Have to know what they mean. Not the roots. Points of the intersection. So if you were to graph these two, there is your x squared plus y squared is equal to 5. There's your x plus y is equal to 3. They intersect at 1, 2, and 2, 1. That's what you figure out. That's what you're doing when you're doing simultaneous equation. You're figuring out either where your two lines intersect, or this term, because we're dealing with a line and a circle, you're finding out where they intersect. That's the whole thing. Right, you're going to do one of these. Right, give you one more minute there, guys, to finish that off. So, as I said, most common place to make a mistake in this is literally the multiplication. Like most leaving cert questions, just getting your multiplication around. Take your time with your multiplication. Right, let's have a little go at it. So, solve for x and y. Y is equal to 2x minus 5, x squared plus xy is equal to 2. We know the top is our linear and our bottom is our quadratic because there's no squares on top and there's a squared on the bottom. In this situation, I know it's done for us already anyway, we chose y to solve for y. Why wouldn't we have went for x anyway? Anyone know? Anyone know why I didn't bring, if this was, just say it was x is equal to y minus 5, why would I try to get y in its own here? See the bottom line? You'd have to square the x by y. Whereas when we're subbing in for y, we only have to sub it in once. But if you solve for x up here, you'd have to square it down here and then put it by the y and just make the question way longer and way harder. Always try and make the question as short and as easy as possible. Because if you solve for x up here, you have more multiplication, more chance to make a mistake, and also you're going to run out of time doing your leaving cert. Plain and simple, you're not going to have enough time when you're doing leaving cert or higher level maths. So try cut down on time wherever possible. Right, y is equal to 2x minus 5, x squared plus xy is equal to 2. Sub it into the bottom line. So that's x to be squared plus x times 2x minus 5 is equal to 2. X squared plus 2x squared minus 5x equals 2. X squared and 2x squared is 3x squared minus 5x. Bring over your 2. Minus 2 is equal to 0. Yeah? Right, can we bracket it? You can. You can also minus b it if you want. 3x and x, minus 2 plus 1. 3x is equal to minus 1, x is equal to minus a third. X is equal to 2. We happy with those? I am now. Yeah? Yeah. We check the top one. So these are our two x values. We sub them back into our top. So our top was y is equal to 2x minus 5. We now have y is equal to 2 times minus a third minus 5. Y is equal to 2 times minus a third is minus 2 over 3 minus 5. What's minus 2 over 3 and minus 5? Minus 17 over 3. Right. Yeah. And then sub it back in again. Y is equal to 2x minus 5. Y is equal to 2 times 2 minus 5. Y is equal to 4 minus 5. Y is equal to minus 1. Very, very important when you're doing higher level maths as well. Box off all your answers and do everything in a straight and neat line, you get more marks. If I see boxes there and I'm correcting papers, I love it. Boom, 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 full marks. Don't have to even look through the question. Box off every one of your answers. Right, we'll do one more of those. We're still a bit sketchy on them. Right, we 3x minus y is equal to 8. X squared plus y squared is equal to 10. Abby, which one are we going to solve for on the top? We're going to try to get y in its own and we're going to try to get x in its own. Y. It's easier. If we try to get x in its own, it's going to be 8 plus y over 3. you always keep the easier one. Right, let's have a little look at it. So, we have 3x minus y is equal to 8, x squared plus y squared is equal to 10. Take out our top. Minus y is equal to minus 3x plus 8. Y is equal to 3x minus 8. You just multiply it across by minus 1 or change the sign to make life easier. Is that alright? Right, sub back into our second one then. X squared plus 3x minus 8 to be squared is equal to 10. You have x squared. What's the quick way for squaring out brackets? Square that. Did we do the quick way for squaring out brackets last time? Square the first, which is 9x squared, plus twice the first by the second, plus square the last is equal to 10. You can square it out normally if you want. X squared plus 9x squared plus minus 24x times 2 is minus 40. 8x. Square the last plus 64 is equal to 10. X squared and 9x squared is 10x squared minus 48x plus 64 minus 10 is equal to 0. So that's 10x squared minus 48x plus 54 equals 0. Right, and divide across by 2 to make it easier. 5x squared minus 24x plus 27 equals 0, right? We have that, minus b it. Minus 24 is plus 24, plus or minus the square root of minus 24 to be squared minus 4 times 5 times 27 all over 2 times 5. You did brackets there, did you? Just double check it. 24 plus the square root of minus 24 to be squared minus 4 times 5 times 27. 3 and 3 and 9 over 5. Yeah, good stuff. What I'll do from here, sub it back into my top line. So we know y is equal to 3x minus 8. Y is equal to 3 times 3 minus 8. Y is equal to 3 times 3 is 9 minus 8. Y is equal to 1. Same thing again, y is equal to 3x minus 8. Y is equal to 3 times 9 over 5 minus 8. And y is equal to minus 13 over 5. Right, as I said, these are grand. Where you're going to make mistakes is inside the multiplication. Is that alright? Take your time on the multiplication, that's the most common place to make a mistake. Right, there's one more type of simultaneous equation. This is the last type. Right. X plus y plus z equals 1. 2x minus 3y minus 2z equals minus 9. 2x minus 3z equals minus 16. 3 variables. So, that has a possibility to come up. This is very likely. They might show this in 2 out of 3 years. Alright, I'm not 100% sure. Can't remember the last year one. Definitely not the year before, that. I'm not 100% sure what the last year. But they love this triple one. The reason they love this triple one is it takes forever to do. If you make one mistake, your entire version. So you literally can't do the same multiplication here, it throws the entire version. Anyone know what the solid is? Yeah, so you split it into 1, 2, 3. You take 1 and 2 together, or 2 and 3 together, or 3 and 1 together. Right. Once again, these are hard maths, you run out of time. You look at this, what should you be thinking straight away? Taking 1 and 2 together, knocking out the z. Why not take 1 and 2 together straight away, knocking out the z? Not the z. Knock out the y's. You're taking 1 and you're taking 2 together, knocking out the y's. Why are you knocking out the y's? There's no way in the power that you straight simultaneous split. Alright? Have a look at it. Take your 10, 15 seconds, 20 seconds to look at it before you go out. See if they're sharp. Right? Take 1 and 2, knock out the y's. out the y's here and do a simultaneous equation with your new one and this. Best thing about these is, once you get your answer for x, y, and z, you know if you're going to get full marks in the session. If you try it, it's give you 1. So you know you're going to get full marks in the session. Always check your answer session, please. Give you a minute there to finish. 1 minute there to finish that. Right. Let's look at it. So, multiply the top one by 3. I'm going to pair it with that one. Call that 1, call that 2, call that 3. 3 times x, 3x. 3 times y, 3y. 3 times z, 3z is equal to 3. 2x minus 3y minus 2z is minus 9. See this little thing right over where I put 1, 2, 3, 1, 2? That isn't for me. Just so we're clear, that's for the corrector. Make the life as easy as possible for the corrector. If they start seeing, geez, I can follow this completely, they will give you extra marks. They will go out of their way to give you marks. If your work is messy, they're not going to bother the whole. You have to remember they get up to 270 to 300 scripts. If your work is messy, they're lazy as hell. Like, they're teachers at the end of the day. They're just not going to bother their whole looking for marks. Make their job easy. 3x and 2x is 5x. Plus 3z and minus 2z is 1z, is equal to 3 and minus 9 is minus 6. Call that 4. Right, put 3 underneath it. 2x minus 3z and minus 16. Right, multiply top line by 3 again. 3 times 5x is 15x, plus 3z, 3 times minus 6 is minus 18. 4, 3. 2x minus 3z minus 16. Gone. 15 and 2x is 17x is equal to minus 34. Divide across by 17. X is equal to minus 2. Sub that back into either one of these and it'll work. I'm going to sub back into 4. 5x plus 1z equals minus 6. 5 times minus 2 plus 1z is equal to minus 6. Minus 10 plus 1z equals minus 6. 1z is equal to minus 6 plus 10. Z is equal to 4. Sub that back into your top one, which was 1. X plus y plus z is equal to 1. X we know is minus 2. Y we don't know. Z is 4 is equal to 1. Y is equal to 1 plus 2 minus 4. Y is equal to minus 1. Let me check them. Minus 2, minus 1 and 4. Minus 2 minus 1 is minus 3. Minus 3 plus 4 does give us 1. Full marks. Go back up and check your answer. They're grand. Once first of all, you make life easier yourself. See if you can spot the shortcut. Right, I left. There was no y in 3, so I knew if I knocked out the y's, it would cut down the work in this an amount. Then number 2 is take your time and get the multiplication right. Get the multiplication, addition, and subtraction right. There's where you're most likely to make a mistake. Right. So that's simultaneous equations. You have your regular, easy, linear ones. Creating the equation is the problem. You then have the linear and the quadratic, and then you have that type of one, which is your 3 variables. Right, let's look at a bit more on the creating the equation. We want to do it with quadratics. So we're back to quadratics and looking at creating the equation. This could be the biggest problem with linear. Right. Teachers organising a trip to cuisine. The total cost of entry for student cuisine is €72. By letting X equal the number of students in the class, write the expression to represent the cost of the trip per student. If 2 students decide to go to cuisine, the total cost of entry will be €70. Write the expression for the new cost per student. Right. The first bit. What am I going to do for the first bit? Add up. Yeah, so how am I going to create the first little bit of the equation? No, it's not simultaneous. We're only dealing with x's. It's quadratic. Faye or Abby, any idea to help them out? So, X is the number of students. Write an expression to represent the cost of the trip per student. Right, Adam, 10 students are going on the trip. How much would it cost them? Ten students are going. How much would it cost each student? That's what they're asking us. Write an expression represent the cost of the trip per student. 720. How'd you get 720? €72 the total cost divided by 10. Yeah? Of those two figures, which don't we know? 72 or 10? Which one did I take a guess on, or I made up? 10. I made up 10. What do we call a figure that we don't know? X. So the cost per student, 72 over X, because we don't know the number of students going. II. Faye, what happens in II? In English terms, what happens in II? Is the same number of students going? No. X minus 2. So the number of students now is X minus 2. Abby, is the price the same? No. It's now. So create an equation for me now. Brilliant. 70 over X minus 2. Adam, back to picking on you. Number 3. The cost of the entry per student in this case will be increased by €1. Write an equation to represent the above information and hence solve this equation. Find the number of students who are originally meant to go on the trip. Right. You went the first day and you went the second day. Are you paying the same amount of money? No. Right. So, what's the first thing we learned in first year about equations? They have to be? Anyone know? They have to be? Like a weighing scales. They have to balance out. So, we'll call this day 1. We'll call this day 2. Are they equal, Abby? Is day 1 and day 2 equal? Are they? I think so. What does part 3 tell us? The cost of entry per student in this case. So X isn't the cost of entry now. X is the number of students. The number of students the first day was X, the number of students the second day was X minus 2. It tells us the cost of entry per student in this case is increased by €1. Write an equation representing the above information and solve this equation to find the number of students. This will be very hard to put in your head. What I like to do is make up numbers and put it in and see if it makes sense. So I'm going to say, if you went the first day, you paid €12. You went day 1, you paid €12. Alright? On day 2, did you pay how much? X is the number of students, so we know X is X minus 2. You went day 1, you paid 12 quid. How much did you pay in day 2? What does part 3 tell us? €1, so you paid 13. You went day 1, you paid 20 quid. How much did you pay day 2? 21. You paid €1 more. So at the moment, is our left hand side and our right hand side equal? No. This side is 1. Bigger. 1 bigger. So what do we got to do to make it equal? We've got to add it. We've got to add it. This now becomes 72 over X plus 1. You got to make it equal. So now it just becomes a fraction equation. 72 over X plus 1 minus 70 over X minus 2 is equal to 0. Multiply across by what to solve it? Don't need to know because I'm an equals in it. What can I do to make it just way easier to knock out the bottom line? get a lowest common multiple of x, and we did these last day. So we just multiply this by x, and x minus 2, this by x minus 2, and this by x, and x minus 2. Right, off you go, solve it for me. Right, so we multiply across by x and x minus 2. Gone, 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 gone. 72 times x minus 2 plus 1 times x minus 2 minus 70 times x is equal to 0. 72x minus 144 plus x squared minus 2x minus 70x equals 0. X squared, 72x minus 2x minus 70x, they all knock each other out. Minus 144 is equal to 0. Difference of 2 squares, x and x, or minus b, whichever you want to do. Minus 12 plus 12. X is equal to 12, and x equal to minus 12. Which one do we accept? 12. And what is 12? Number of shootings. And how many shootings went the second day then? 10. Alright. Do we answer the question? Solve the equation to find the number of shootings or regiment to go on the trip 12. Right, have a go at this one so on your own. Same thing again, create the equation. That's the big problem with these. Solving them is easy. It's creating the equation we want to do. The trick is to make sure you label them right. So label what x actually is. Label what you're actually doing in your equation. Motor school play a class undertook to make 100 posters with each pupil making the same number. There were x pupils in the class, and even tell us what x is. So your first equation is the number of posters made by each in terms of x. So as I said, you can't work it out. Just say it to yourself in your head. If there were 5 pupils in the class, how much each? How many posters did each one make? If there was 10 pupils in the class, how many posters did each one make? Pick a figure if you can't figure it out. That's what I always do. So it is the last. Think about it in your head. You made more posters the first day or the second day. No. Think about it. You were making more posters the second day because it tells you had to make one more because there was 5 students out. So then you gotta think in your equation terms, is your left hand side equal to your right hand side? So as I said, put a figure on it. You had to make 9 posters the first day. The second day you had to make 10. Is your left hand side equal to your right side? No. Right, let's look at it. So, to promote a school play, a class undertook to make 100 posters with each pupil making the same number of posters, I. If there were X pupils in the class, express the number of posters made by each in terms of X. Abby, how do we create the first statement? Brilliant, 100 over X. Adam, how do we create the second one? Brilliant. So, we now create our equation. 100 over X is equal to 100 over X minus 5. It's not though. It tells us when 5 pupils were absent, each pupil present had to make 1 extra poster. Right, the first day you had to make 9, and the second day you had to make 10. Are they equal? No. What do we need to do? Add 1 to the left. 100 over X plus 1. You got to add 1 to the left to make sure that your left hand side and your right hand side is equal, or else your equation doesn't balance out. 100 over X plus 1 minus 100 over X minus 5 is equal to 0. Multiply across by X and X minus 5. So that's 100 times X and X cancel. It's 100 times X minus 5 plus 1 times X minus 5 minus 100 times x minus 5 and x minus cancel, leave it with x is equal to 0. 100x minus 500 plus x squared minus 5x minus 100x is equal to 0. That's x squared minus 5x minus 500 equals 0, because they go. 500 should leave a difference of 5. 25 and 20. Is it? Check it. Yeah. Bracket, bracket, guide number minus b, whichever you want to do. X and x. 25, 20, minus 25, a plus 20 to give us your minus 5. X is equal to minus 20. And x is equal to 25. Right, we've got the answer. Obviously it's 25, you have to use a positive one. Now we go back and look, have you answered the question? Always go back up and look, have you answered the question? 2 seconds after. Right, the question asks us, on the day they were making posters, calculate the number of students normally in the class. So is x the number of students in the class? Yeah, it is. All right, always go up and check. Sometimes x isn't what they're actually looking for. They could be looking how many posters did each student make, and x equal to 25 wouldn't be the answer there, because we said the actual answer there would be 4. 25 into 100, which would be 4. Always go up and make sure that you answer the question that they're looking for. All right, because you will drop 2 or 3 marks by not actually answering the question. But we did answer the question there. Right, boys and girls, that's half 11. Good stuff.